We don't discuss this so much. Yeah, I can move on with that. But the clearer the sound, but the quality, you have a more clear sinus wave, as we say that here. Yeah, okay. Not so important. Okay. Okay, this is interesting. The diagram opposite shows the appearance of a sound wave on an oscilloscope. Draw a second diagram showing the appearance of a sound wave, lower pitch but higher loudness. Please copy and try to make another wave inside this diagram and see the difference. And what do we see? Indeed, we have a lower pitch. Look at the wavelength, the distance between the two tops, much bigger, and look at the amplitude. This one is much louder, okay? Okay. Again, when we have talked about already, yeah, when we want to make some measurements on the oscilloscope, this is the time period, because in the oscilloscope it is like divisions in time, yeah. Then we have t. How can we then calculate the frequency? Remember that is 1 over t, yeah, and that is, example, if t would be 0.05 seconds, then the frequency would be 20 Hertz. Okay? Alright. Question. The distance between the two peaks, 4 centimeters. Now it's different, 4 centimeters. Okay? You say 1 millisecond per centimeters. What would be the frequency of the sound? Pause the video and make your calculation. Okay? So we have a time of 4 milliseconds. F is 1 over t, and then we get a frequency of 250 Hertz. Okay? Now, ending with this slide, and then we more or less have covered the whole section of sound. Okay? Sound is a longitudinal wave that in air consists of a series of compression and rarefactions. Sound travels faster through solids but does not travel at all through a vacuum. A reflected sound wave is called an echo. Sound also undergoes reflection. On average, humans can hear sound between frequency and 20,000 Hertz. Okay? Alright, I wish you a good weekend. Again, don't forget to make notes, pause the video, and I hope to see you soon. Later on I will send you the links and you can do some experiments online. Okay?